Latitude Media, covering the new frontiers of the energy transition.
Back in January, Steve Oldham was sitting in a conference room with a group of reps from his company's first potential customer, and he was stalling.
On the morning of the customer visit, the system was still not working. I think I got there at 7 a.m. or something. The team had been there since 4 a.m. Customer was coming at 9 o'clock, and at 9 o'clock still hadn't been able to turn it on fully yet and fix all the leaks.
The leaking system was a first-of-a-kind technology for pulling carbon from the ocean.
We told the customer we would be good for the end of January for what would be a very important demonstration of the technology.
Steve is the CEO of Captura, an ocean-based carbon removal company. He and his team had been racing against the clock to pull off this demonstration. Captura had planned to build the pilot in Norway at the facility of another company, but that plan fell through. Unfortunately, Captura already had equipment en route to Norway, and the facility they'd found as a backup was in Hawaii, half a world away.
And so the race for us was, could we get the equipment to Hawaii fast enough to install and get it commissioned and working in time?
And so how did that go?
It was scary. The technology arrived in individual shipments. I remember over the Christmas holiday, there was one final piece of equipment, actually the control center computers, but it was coming into Baltimore. And so to leave Baltimore and ship round the Panama Canal and everything would take too long. So we were able to persuade the shipping company to take just our container off in Baltimore. We then had somebody drive it across the country to Los Angeles, where it jumped on another boat that was going to Hawaii. And that way we got it there in time.
But then the Captura team had to show the customer that everything worked.
When I got there 3 or 4 days in advance, the system we still had, the first leaks. Has something been tightened properly, and all these types of normal things that you have. We had a great team there working day in, day out.
And the team kept working all the way up to 9 a.m. on the day the customers arrived, which brings us back to that conference room. Steve was sitting with the very people he wanted to impress, and they still had no idea the system had a serious plumbing issue.
So I did my best, along with another employee, to entertain the customer for an hour in a conference room.
But there's only so much stalling that they could do. In the end, he had to have faith that his team would pull it off.
And then the team told me that we've just turned it on. It's been running 2 minutes. We think it's working. Bring them down.
I'm Lara Pierpoint, and this is The Green Blueprint, a show about the architects of the clean energy economy. We've already invented most of the solutions needed to decarbonize the global economy, but many of these technologies are not yet commercial. They need to get financed and built at scale. We don't have decades to get them commercialized. We have years. This week, I'm talking with Steve Oldham, the CEO of Captura, about ocean-based carbon removal and the arduous journey of demonstrating the viability of a first-of-a-kind CDR technology.
Our safety guy gave the longest safety brief that I think anybody could imagine, to give the team time to sort of tidy up everything, put all the tools away, and then we brought the customer out, and everything worked first time. The team had built the pilot, commissioned it, got it operating in just 70 days.
Before we dig into Steve's story, it's important to know why Captura is trying to remove carbon from the oceans in the first place. It starts with some science. When you remove carbon from the ocean, it also removes carbon from the atmosphere. Think of it like a can of soda.
When you open the can of soda and you pour it into a glass and put it on the table, a couple of things happen. Firstly, all these bubbles come up. And then secondly, the drink goes flat.
When there's too much CO2 in a fizzy drink, the excess gas escapes into the atmosphere, making the drink go flat. The carbon wants to be in balance. That's Henry's law, a principle of physical chemistry. But Henry's law works the other way, too. If the CO2 in a liquid is too low, it will pull CO2 out of the atmosphere until it reaches equilibrium. Captura takes advantage of this dynamic. at a planetary scale.
So we take CO2 out of the ocean, and then the ocean, due to Henry's law, takes the CO2 out of the atmosphere.
In 2021, two Caltech professors, CX Chang and Harry Atwater, were trying to turn the scientific concept into tech reality. They built a desktop prototype, but the vision was bigger, a major facility that could handle tons of ocean water.
When the ocean water comes in, we take out a really small percentage of it, about 0.5%.
Then, special membranes split that 0.5% into an acid and a base. Next, they add the acid back into the other 99.5% of ocean water.
And at that acidity level, you get a reaction between the dissolved inorganic carbon within the ocean, and it becomes a gaseous CO2 that you can then extract.
Finally, the base goes back into the ocean water to re-neutralize it.
And that's what goes into the ocean.
The goal is to create a closed-loop process that pulls CO2 out without added chemicals. Just ocean water in, ocean water out. A few months after Chang and Atwater founded the company, Steve Oldham came on as CEO. He had served as the CEO of Carbon Engineering, a company doing direct air capture, or DAC. Captura believed that its ocean-based technology would have a few advantages over DAC. For one, it's easier to remove CO2 from the ocean, where it's 150 times more concentrated. Plus, it pairs well with renewables.
Direct air capture typically requires a continuous level of power. We've designed our system to work with very intermittent and even curtailed energy for the majority, if not potentially all, of our energy use.
And there's a surprising ecosystem benefit. As the ocean warms, it absorbs more CO2 and becomes more acidic, harming coral, oysters, and other shell builders. That's called ocean acidification. But removing CO2 from the ocean reduces that acidity.
So we are ultimately taking CO2 out of the atmosphere, like direct air capture and other forms of CDR. But we're also at the same time helping with the problem of ocean deacidification.
So you're helping to create happy coral reefs, right?
Absolutely, yes.
So in 2021, with some compelling research, a desktop-sized prototype, and Steve as CEO, Captura built its first pilot, about the size of a refrigerator. Steve's team set it up on a pier at a Caltech lab in Newport Beach. I talked to Steve about Captura's journey, from a 1-ton pilot to a 1,000-ton operation, and the many hurdles they faced along the way, starting with its first major challenge, salt. When you were building at Newport Beach, this was the first time you were really interacting with ocean water instead of just kind of a lab-based process. Is that right? So what did you learn from sort of the real-world moment of working with actual ocean water?
So one of the challenges of operating in the ocean, of course, is it's a corrosive environment due to the salt. So membranes can corrode in that environment, which leads you to question the feasibility of the solution, the economics as well. We developed a backwashing mechanism. So we'd actually regularly wash the membranes using the chemicals that we produced in the process. And that eliminated the fouling problem. So that was a big tick in the box for one of the big technical risk areas.
So you've got a really important proof point, a really important innovation coming out of Newport Beach, and now you're deciding what to do next. So talk a little bit about your decision to scale up from 1 ton to 100 tons. Was that an easy decision, or is that something that you had to really think about, the sort of scope of the scaling you'd do?
Physical sizing of the scale-up was decided by the physical area inside that roll-up garage. We hired a wonderful pilot engineer from Caltech. And I remember the first time I went into that garage after she joined, she had marked out on the floor where all the equipment was going to go. So there was very small areas to walk through. And so the equipment essentially filled that garage. There was kind of no more space. And it turned out to be roughly 100 tons. So as much as anything, I mean, there's obviously the sort of the headline of scaling up 100 times rather than 70 times or something like that. But as much as anything, it was decided by the physical land area that we had.
Very cool. So tell us about the Alta Sea organization. What made you decide to place your next big pilot there?
Yeah, so Alta Sea is a really interesting thing for anybody who's down at the Port of Los Angeles. They are a not-for-profit. They were supported by, I think, the city of LA and the state of California. And their objective is to improve understanding of the role of the ocean in our everyday lives and to support companies that are doing things of benefit to the ocean. So there's a dock where you can put a barge and then you can put your experiment, for want of a better word, on the barge. You obviously have to go through a permitting process to make sure it's okay. And then you can run. So we've been there, I think, 2 years now. It's been a really good relationship.
So you've got a good partnership. You know where you want to build this. You have your location, your garage, as it were, stuffed to the gills, getting ready for all this equipment that you're going to bring in. Talk about how it went, scaling from a 1-ton system to a 100-ton system. Did everything work as you expected as you were making that pretty big leap and scale up, or were there some challenges you had to confront?
Yeah, I think it's fair to say there were some challenges with that leap up. That was our first end-to-end system. So we were doing more than just the electrodialysis step, which is what we were doing at Newport Beach. We were also doing the degassing, where you physically strip the CO2 out. That gave us some challenges. The technology that we were using at the time, membrane contactors, it was difficult to operate, and the supply chain was challenging for us. So we actually went through 2 suppliers, which delayed everything there in setting up the barge and getting to the end-to-end system. So I can't remember how long it took, but it took several months for that first system to operate successfully end-to-end. We also had a design goal that we wanted the system to work in batch mode, by which I mean we could test each individual subsystem, or we could test the whole system. So that meant, for example, we had intermediate tanks for the various intermediate states of things inside the system. So the design of the system was complicated. So that was quite a significant time of development, but ultimately really, really pleased with the progress. The system worked fine at the end of the day.
This is very cool. I want to just ask one follow-up question about this, because I think this is a topic that comes up again and again on the show, the question of what should the scope be, particularly as you're building pilots or demonstrations on your way to something that's going to look like a fully commercially operable system. And I think startups, again, are constantly facing this tension. Like, do you push really hard to the system that is going to be the thing that is commercial and make things as commercial as possible, as quickly as possible? Or do you take an approach that's more similar to, it sounds like, what you did, where you're really thinking about, we have to build this pilot in a way that we can individually test the pieces of this, and that's going to add complexity and it's going to add time. So were you grappling with a lot of those tensions? Like, were those hard decisions around whether you sort of move as quickly as possible to something that looks as close to a commercial system, or was it always obvious, I guess, how you really scope the things that you're doing as you're getting through these demonstrations?
That's a great question. The way that we approached it was start at the end. And what I mean by that was we had a techno-economic analysis of what we wanted a full-scale system to look like in terms of cost. But also critically, when you do a techno-economic analysis, you need to know what the performance of your various subsystems is going to be. So I'll give you an example. As water moves through the system, the amount of CO2 you extract is a critical performance parameter. If it's 10%, you're moving a lot of water for very little CO2. If it's 95%, your economics are much better. And so the pilot was designed to demonstrate the KPIs of each individual piece of equipment. That goes back to the philosophy of wherever you can, test in the small.
Okay, so among the challenges that you deal with as an ocean carbon capture company is the question of your impact on the environment, and specifically on the marine environment. So can you say a bit about how you thought about that? Because obviously we know that there are some benefits from deacidifying the ocean, but also some big questions about what technologies like this might do to the marine environment. So how do you think about that, and how did that pop up in your permitting process for the Alta Sea project?
Yeah, good question. So ocean health is integral to what we do at Captura. It's always been a fundamental thing. We hired an oceanographer very early on in our company's history to ensure that we were doing the best possible things with respect to ocean health. So our process adds nothing to the ocean. We do not put any new material into the ocean whatsoever. The only thing we do is take out the CO2. So quite correctly, there is a lot of regulation around what can you put into the ocean. California has some of the most tough wastewater standards in the world. They define things like what's the pH level, the alkalinity, the oxygen levels, the soluble solids within the outflow, within anything you put into the ocean. Our process is consistent with those standards. which means that we fall within the existing permitting regimes. So then we also wanted to test that our ocean water, as it comes out of the back of the plant, does not have any negative impacts. So we work with local aquaculture companies. We look at marine life. We grow marine life in our outflow at various concentrations to confirm that we are having no detrimental effect. We model how our outflow plume of water rapidly disseminates into the wider ocean and validate that within a very small distance from the outflow, the ocean water is all returned to its natural state because of mixing. So we do all of that with the review of third parties, and everything is published on our website for people to take a look at.
Very cool. So at the end of the day, what did you learn from the AltaSea project, and did you meet your performance milestones?
Yeah, the short answer is it works. We established we were doing CO2 capture. We were able to test each subsystem in isolation, confirm the KPIs that we wanted. We started our ocean health campaign. We had those sensors, our little Captura boat. We wrote the software for monitoring the entire system. Essentially, everything was good. So then we were ready to build a next scale up, which we wanted to be a full end-to-end system, which could be run with the minimum human interaction.
Let's talk for a second about what's going on at the company, though, because this is a time when you're starting to raise some capital and forming some new partnerships. So can you say a bit about how you were thinking about the company development, the kind of capital you raised, and the folks you started speaking to for some partnership opportunities?
Yeah, I have a fundamental philosophy that small companies like Captura need help to solve really big problems. And that's what I did at Carbon Engineering with Oxy. At Captura, what we wanted to do was attract actually more partners so that we had different partners around the world from different sectors. So during our fundraising, which was 2021, 2022, 2023, we looked out to find as many strategic partners who could help us with deployment, with questions that we had about, for example, renewable energy, with end use like airplanes, like marine logistics. These are tough to decarbonize sectors. So we wanted people on board who understood those problems. So we raised what turned out to be eventually $47 million in our Series A. We did it in a series of increments as more people came to us. We were able to increase the valuation of the company as we progressed. And we actually now have 8 strategic partners who are investors. So we have a couple of energy companies in Equinor and Aramco. We have 3 renewable energy companies, Eni, EDP, and National Grid. We have what we love to call our Team Japan. Japan has a lot of interest in this technology for its decarbonization journey. So Hitachi, MOL, and Japan Airlines. And then we also have Maersk, of course, global logistics company with quite a significant decarbonization challenge. So we pulled all of those partners in, delighted to have them on board. They all actively help us with questions and engineering and access to people. It's been really good.
So let's talk a little bit about the project that you were then planning to build. So originally, you were planning to build this project with Equinor in Norway, but you wound up in Hawaii. So tell us a little bit about what happened there.
Yeah, so Equinor was our lead investor at the start of Series A, has been highly motivated and interested in our technology to help with their decarbonization and as a business opportunity. So they had expressed interest in working with us on the pilot and identified a site in Norway that could accommodate that. We actually announced to people that we were planning to put our 1,000-ton pilot at Kårstø. Kårstø is the Equinor gas processing facility on the coast of Norway. And of course, that's become a mission-critical facility given the global challenges with Russia and the uncertainties around gas supply in Europe. So we worked with the Equinor team in figuring out where it was going to go inside the plant. But ultimately, Equinor approached us and said, look, this is difficult for us to do. It's difficult for us to bring new technology into a mission-critical facility, obviously a safety-critical environment with gas processing. Some of the technology that we were using did not conform to the safety standards that they correctly have at that facility. So we had a choice to either make sort of fundamental changes to the technology's supply chain to get to that safety level that was required, or go somewhere else. And the reality was to do the first thing would have taken probably about another year. And in startup world, time is money and time is critical. So we sat down with Equinor and we said, look, it's just too hard for us. We understand why you can't take this technology in at this time, but we can't wait. So Equinor were terrific. They understood the problem. And we at Captura went away to look for another location. And that's how we found Hawaii and the Nelha facility at Kona. It's a Hawaiian state-run experimental facility. And they had a space, and they already had the ocean water coming in and then back out to the ocean again. So all we had to do, I say all, it makes it sound easy, but we just had to plug into that water line and then move the equipment that was all heading to Norway and instead divert it to all head to Hawaii. Of course, it's not exactly on the way. So that took, I think, the best part of 3 months to get all the equipment there.
So was this an agonizing decision? I mean, it sounds like it must have been. If you've literally got equipment on the way to Norway, you've got this incredible partnership. Was it hard to decide ultimately to reroute this and move to Hawaii? Or was it really clear when you kind of ran the numbers on this that it made tons of sense?
Yeah. Now I think back on it, it was an easy decision to make because of the lack of choice. Sometimes making a hard decision is easy because it's the only decision you can make. The process of implementing that and getting everything that was heading to Norway instead getting it to Hawaii, that was not easy. But the decision was easy because it was the only one we had.
I mean, there you go. Nothing like an easy decision, even when it creates some headaches, right? So there was another piece to the puzzle here kind of looming over you, which is that your project in Hawaii, this was the first time you had customers, right, who were going to be purchasing effectively offtake from the project. So tell us a little bit about who these customers were and how you came to these agreements with them. And then let's get into how that affected your project build.
We had been explaining the benefits of direct ocean capture to a number of entities that are interested in CDR, in carbon credits, but they needed a working end-to-end pilot. As I mentioned, the system at AltaSea was more of a batch mode. It wasn't continuous mode. Customers want to see, hours of continuous operation. So we had a customer team that was wanting to come out at the end of January this year.
Which brings us back to that conference room moment from the top of the show. The equipment had arrived, but the system was leaking. So Steve and his colleagues were stalling the customer reps while the Captura team scrambled to get the pilot up and running. More on that after the break. How did it feel as you were sitting there entertaining this customer and you finally got the text that said it's been working for 2 minutes? Was it the most relief you'd ever felt?
Yeah, it was very stressful because, of course, the customer had flown all the way out to Hawaii for the demonstration, and we backed ourselves that we would get it running in time. Went right to the wire. But that kind of thing it builds teams, and it's a company story that will last forever. I'm incredibly proud of the team. So yes, it was terrific.
So what was the result? Did the customer ultimately sign on for a substantial contract for offtake?
Still working with them. All good. We signed our first offtake contract in March, and are in negotiation with several others at the moment. So yeah, looking forward to developing on that.
And so say more about what that's going to look like. So what are you going to build next ultimately? And how are you going to ultimately serve these contracts?
Yeah, the way we think of where the company's at now, we think we've proven all our technology. It works. We've got hundreds of hours of continuous operation with no degradation. Much of the scaling from here becomes replication rather than physical scaling. So we're ready to build our first plants. We are currently looking at a number of sites to determine which one we think makes the most sense. Some in Europe, some in North America, Asia, potentially the Middle East as well. I mentioned that our Hawaii plant took just 70 days to install and commission. So we think the plant can be built pretty quickly. So we're targeting 2028 to be in operation with our first commercial plant.
Very cool. And as you're thinking about financing that first commercial plant, do you anticipate that the first one or two of those will involve a lot of kind of venture equity or investment from strategic partners? Or do you think you can start to attract some non-dilutive project financing to get those built?
Yeah, I mean, I hope non-dilutive project financing. One of the hardest things, and one of the many hard things at a startup, is once you have your technology working at a level that you believe to be adequate, is taking that technology out and building your first commercial plant. Because the perception of risk is there in the eyes of whoever might finance. Plus, you need customers, and those customers are concerned, is the technology going to work? So pulling those things together and producing a fully project financeable first plant, like, for example, I don't know, a solar field now can be pretty easily project financed. The technology is fully proven over many years. The market is well understood. The price points of the market are well understood. So, project financiers are happy to come into that deal. But you go to them and say, hey, I've not scaled my technology past 1,000 tons. Nobody really knows the price point of the carbon market. I'm working on offtake. Trust me, I'm going to get it. Please lend me a ton of money. That story can be challenging. I think we have all the building blocks in place. So we'll work to see how that plays out. It may end up being a combination of project finance and equity type finance, maybe a partnership. My approach is really simple. Keep all options on the table and keep progressing, keep ticking off the risk matrix and showing that the things people are concerned about have been addressed. So we'll see exactly what the final deal looks like.
So let's talk a sec about the demand side of the equation, because you mentioned that, to put it mildly, I guess the price is not exactly assured when it comes to selling credits into the carbon dioxide removal market. So what are you seeing, and how have things changed, especially now that there are many companies kind of pulling back from their sustainability goals?
Yeah, I think it's a really challenging environment for everybody. I've been in the CDR space since 2017. I've seen a lot of changes. When I started, just getting anybody's attention whatsoever was really difficult. And then you started to get some early adopters interested. You started to get government interested. And things were progressing towards a point at which you could see that there would be a global consensus that there should be prices on carbon. Carbon should be a tradable item. The last few months has moved away from that, certainly in the United States. And of course, the danger is that other parts of the world say, well, if the United States isn't going to address climate, why should we? The good news is that there are many countries that see the opposite, which is if the United States is pulling away from climate leadership, maybe the companies in our country can lead this and we can develop a brand new industry to the benefit of our economy. So what I would say is the early adopters, there are companies like Microsoft, Frontier, and others that are seeking to create a market and build a supplier base. I see those companies providing the leadership in the market. They're doing it for good reasons for themselves as well, securing a first right to buy future capacity from the most promising technologies at the lowest costs. So what I hope happens is those early adopters are enough to allow the best technologies to get to market. Then governments will see, and policymakers and the general public will see that there are solutions that are affordable for climate, and then regulation will start to come in. I've always felt that no policymaker is going to establish a policy that's not feasible, because then it just comes back to bite them. So it's on us as the CDR industry to demonstrate that we're feasible and cost effective. We do need early adopter customers or government support for that to get to that point, just like almost every satellite that's up in space now doing all the things they do for humanity started because governments paid for the first satellites. That's the type of start that new industries will need to get to market. So I hope we'll see the market evolve. I think we will. And I think we'll get past this current challenge with the US because the rest of the world is looking at it as an opportunity for them.
I think that's a fabulous note to end on, especially because it's a hopeful one and a good reminder to all of us in climate to grit our teeth, and we're going to get through this. Thank you so much, Steve. This has been incredible. I really appreciate you joining us on the show.
Great. Thank you.
The Green Blueprint is produced by Latitude Media in partnership with Trellis Climate. The show is hosted by me, Lara Pierpoint. This episode was produced by Daniel Woldorff and Erin Hardick. Ann Bailey is our senior editor. Sean Marquand is our technical director. Stephen Lacey is our executive editor. If you'd like to suggest topics or guests for the show, send an email to the Green Blueprint at latitudemedia.com. You can listen to the Green Blueprint at latitudemedia.com or subscribe wherever you get podcasts. And if you have fellow clean energy or climate tech travelers who would benefit from the insights in this show, send them a link. This is the Green Blueprint, a show about the architects of the clean energy economy.